Hi class, in this video I'm going to demonstrate how to do everything that we just learned how to do in the one sample T hypothesis test and one sample T confidence intervals videos, only this time I'm going to demonstrate how to do it using the Math 221 Statistics Toolbox. So in our class we kind of have two options for Excel tools that are going to help us do all of our statistical analysis. So one option is kind of the older worksheets that were developed by the department, and that is what was used in the previous video, which included the quantitative inference procedures and quantitative descriptive statistics Excel sheets. Now recently the department has developed the Math 221 Statistics Toolbox, which actually takes everything from the whole semester and puts it into one Excel tool. And on top of putting everything together, it's made everything look a little bit prettier, and it has a few more things that are more easily at your disposal. So the 221 Toolbox is really a valuable asset for you this semester. So let me show you how to do the M&M's problem here in the Toolbox. So first off, then I want to make sure I'm in the one sample t-test. We're looking at one sample, my sample of M&M weights. So I click on one sample t-test. Then over here on the left, I'm going to paste in the data. So I've got my data all pasted, or you can enter it in to the side if it was your own data. Next, to do my test, I need to make sure that I have the right hypotheses over here. And this is very important. This is probably where most people get it wrong on the exam. So first off, I need to enter in the value under the null hypothesis. So if you recall from the last video, we were trying to see if M&Ms, peanut M&Ms, weighed differently on average than the weight stamped on the bag. And the weight stamped on the bag was 49.3. So I'm going to enter in 49.3 into my little yellow box right over here. Next thing I need to do is make sure that I have the appropriate alternative hypothesis. In my case, I wanted to see if the M&Ms weighed differently on average. So that would be keyword for not equals to. There are other options. If you click here, there's a little drop-down box, and if I had wanted to know greater than or less than, I could choose that here as well. So I'm going to keep it with not equals to. And when you look here in the toolbox, I love how it's set up so that the hypotheses actually look exactly how they would look if you wrote them down on your piece of paper. So once you've entered in the value under the null hypothesis and the alternative type here, then you'll get your test statistic, in this case 7.845, and your p-value over here. So p-value 0.000, that's really small. And when p is low, then HO must go. So we would reject the null hypothesis and conclude that the peanut M&Ms weigh more than the amount specified on the bag. Our alternative was not equals to. I was able to conclude more than because my sample value was higher than the hypothesized value over here. Now the requirements for doing the one sample t-test are that either my sample size is large or that my population is normally distributed. So in this case, my sample size, which you can see over here in this numerical summaries box, was 26. So it wasn't quite 30, so I don't meet the requirement that way. But, and this is one of the awesome things about the toolbox, I think, is that if I scroll over here a little bit, you can see that with no extra work on my part, then it automatically creates a QQ plot of the data for me. So here's a QQ plot of the data. In QQ plots, we're looking to see if the points fall on a straight line. If they do fall on a straight line, then we consider the data to be normally distributed. And looking here, this looks fairly close to the straight line. So we'd consider this data to be normal and that we would meet the requirements. Another way we can kind of check for normality is to look at a histogram of the data. And again, inside the toolbox, we automatically get this histogram over here. Now, as I look at the histogram that it gives me, I can see that it's kind of all bunchied up over here with a lot of white space over there, which makes it a little bit hard to read. But I can change that really easily in Excel. If I just double click on this axis down here, so I'm just double clicking on this bottom axis, it brings up a whole bunch of tools over here that I can adjust how my graph looks. And if I look at the bars here, I can see that pretty much all the data is between about 45 and 60 or 65 over here. So rather than having my axis go from 0 to 70, which is a little excessive, I think, I'm going to change it, which I can do right over here under the axis options, to go from 45 to 60. Now, look at this histogram. It's a lot easier to read than it was before. It's easy to see that we do have a pretty bell-shaped symmetric distribution going on here, which again indicates that we do meet the requirements for doing this test. So we can do a hypothesis test in here. We can also do a confidence interval. The important thing to remember for the confidence interval is making sure that we have the correct level of confidence that is specified in the problem. So the confidence level can be changed by this little yellow box up here. You can type in a number, or when you click on it, it gives you the option for this little drop-down box over here. In my previous video, I used a confidence level of 95%. So I'm going to go ahead and change this to 95% here. And when I do that, then I get the lower and upper bounds for my confidence interval. And it also tells me the margin of error, which is something that it doesn't tell you in the quantitative inference procedures spreadsheet. You can figure it out based on the numbers, but sometimes it's handy if it just goes ahead and gives it to you like it does here. So that's how you do a one sample t-test using the Math 221 Statistics Toolbox.